So this was the last week quiz, which was related to topic light, the second light pop quiz too. The first one, figure 7.1, shows a ray of a light which is passing through an optical fiber. The optical fiber is made up of a glass and which is having a refractive index of 1.4. So if it is made up of glass, glass is a transparent material. So what should happen? Like if we were having this optical fiber or fiber optic, then when the light is moving from glass to air, so it will bend away from the rod. This should happen because at this point, when we draw the normal, the angle of the incidence is more than the critical angle. So instead of light is going out from the optical fiber, light will reflect back in the same medium. If this angle is less than critical, the light will refract. If this angle was equal to critical, the light will refract at an angle of 90. But if it is more than critical, the light will undergo a total internal reflection. So no light is refracted at point P and Q. So state the name given to this process. So we call that as a total internal reflection. Some of the students write that is a reflection only. That is not correct. Because the reflection, if it was a mirror and then the light changes the direction, then you will say reflection. But if it's a glass, a transparent material, and the light is reflected, so what should happen practically? Like likely, it should refract rather than reflect. But it is reflecting, so what it shows the total internal reflection. Then calculate the minimum angle I for no refraction to occur at point P. So minimum angle I, what does it mean? We need a critical angle. Okay. So simply, like we want to find what will be the critical angle, because critical angle is a minimum when it will travel at. So it can be more than, but minimum angle will be critical. So we have to find a critical angle. And what is the formula which relates the critical angle and the refractive index? The refractive index equals 1 over sine C. So refractive index in the question is given 1.4. So we write 1.4 equals to 1 over sine C. Because we need critical angle, so we cross multiply, sine C will multiply, and 1.4 will be in division. So sine C is equals to 1 divided by 1.4. 1 divided by 1.4, what's the answer? 0.71. Yeah, but critical angle is like when the angle is equals to critical angle, that moment the light will travel at a 90. So first we find the critical angle, and the angle which we predict should be a bit more than that. Because for first what we are doing, we are finding a critical angle. We are finding this angle of incidence. If it was a critical angle, then the angle of refraction should be 90. And what should be the value when no refraction will occur? So it should be a bit more than the critical. So first we are finding a critical angle, and our answer will be a bit more than the critical angle, so that there will be no refraction. All of the light will reflect. So n is equals to, so we have sine C equals to 0.714. And if we need C, sine will go other side. So this becomes sine inverse. So sine inverse 0.714. What's the answer for sine inverse 0.714? So minimum angle, like this should be 46 when it will refract. So this should be more than 46. You can say 46.5. You can say 46.1. You can say 46.2, 46.3. That will be the angle at which the light will refract, like reflect back. Okay. Is it clear? So first we work out the critical angle. When it is critical angle, the angle of refraction will be 90. And there will be a refraction, but the angle of refraction is 90. And we work out that the critical angle is 46. So this should be more than 46, a bit more than like 46.1, 46.2 for a total internal reflection to occur. In this case, the angle I is more than the critical, but what we are finding a critical angle. If angle I, yeah, this is right. This angle I is more than the critical angle. So what we are doing, we are finding the critical angle, and for a total interreflection to occur, for no refraction to occur, this angle I should be a bit more than critical. So first we work out the critical, and then when we want to predict, we predicted like if critical angle is 46, if this angle was 46, how the light will travel? It will travel at 90. If this is 46, so this should be a bit more than 46. You can say 46.1 degrees. When it is 46.1, there will be no refraction, and all of the light will reflect back in the same medium. Is it clear? Anyone having a doubt? Yes. Okay.
No, that's it.
The next is, in this question, figure 6.1 shows an arrangement of a glass prism inside a box. The angles of the prisms are 45, 45, and 90. This device is used to view the objects. This is like this is a periscope, that objects that are behind the ball, the incident ray undergoes a total interreflection in the prisms, and on figure 6.1 complete the path of a ray and it emerges from the box. So it undergo a total interreflection. So first, when a light is passing, it will, because it is passing along the normal, so it will pass straight. Once it hit the glass to air boundary, it will undergo a reflection. When it hit this air to glass boundary, it won't stop. It will continue to move in a straight line because it is passing along normal. And once it hit a glass to air boundary, because the angle of incidence is more than the critical, so light will undergo a total internal reflection. So light strike the glass, undergo a total internal reflection, strike the glass, undergo a total internal reflection. Why the light does not change the direction at these points? Like at this point, why the light does not change direction? Because it is passing along normal. Why it does not change the direction? It is passing along normal. So these points, because it is passing along normal, that's why the light does not change the direction. And the next is show that the refractive index of a glass with a critical angle of 45 is 1.41. So we have the formula, the relation between refractive index and the critical angle. The refractive index equal 1 over sine C, 1 over the critical angle. So 1 over sine and 45. So 1 over sine 45. So sine 45 is like 0.707. So 1 divided by 0.707, we get 1.41. So the refractive index is having 1.41. And refractive index does not have a unit because it's a ratio comparison. So you don't write a unit, you just write the number. So this was a pop quiz which was related to topic light.